All right, so there are two problems here that I think need a little bit of extra attention. And the first one is this one, part D. We want to find f of 3 and f of 4, but we know that we don't have the graph of f. We have the graph of f prime. So how could we find f of negative 3, that's what I meant to say, and f of 4? Okay, let's look at this for a second. So we want to, let's see, we want to find, sorry, trying to use a new tablet here, and it's not amazing. Not even close to amazing. See if I get any better in a second. F of 4. Now those are F's, of course. Okay, so it looks like it's going to be the mouse for now. We'll figure this out some other time. So if we want to find f of negative 3, well, that's here, right? And we see that f of 0 is 3, right? So if we knew that, we know that we want to find f of negative 3. And we want to get, we have this value f of 0 right here. This is important. So if we integrated f prime of x dx from negative 3 to 0, we'd get what two things would, little f prime would become regular f, and what values would we be plugging in? We'd be plugging in 0, and we'd be plugging in negative 3. Okay? So we should have an equation like what this equals, because if we look at this, we can't actually integrate it, but we can find out the area here and here, right? And that will help us to understand what's going on. So what's the area of this triangle right here? Well, this triangle I think has an area of positive 1/2, I believe. And this triangle right here, it's 2 by 2, a half of that. So I think it's an area of negative 2. So this whole thing has an area of negative 1.5. Negative 1.5. The integral is negative 1.5. The area is negative 1.5. And now to get f of negative 3, we just want to rearrange this equation. We know what f of 0 is. It's 3. So 3 plus 1.5 by just simple algebra would be f of negative 3. So that would be equal to 4.5. So that process is super important. We need to kind of understand that. That's pretty much what I'm trying to get at with this whole entire thing. So let's think about this one more time. So we also want to know f of 4, which is, over here. And the question is, what values do we even have that can help us? Well, we still just have this f of 0. So if we integrated from 0 to 4, right, of the derivative, right, we can find that by just doing the work. Okay, this should have a dx, by the way. We can find that by just doing the work. So by doing the areas out, right? But that would also equal, right, we know that's going to equal f of 4 minus f of 0. Okay, you might have to listen to my voice because it's not the best here. So f of 4 is what we're trying to find, minus f of 0, which we know to be 3 from above, and then we need the area of this thing. We just need the area here. So what is the area that is here and here, right? What's this area? Well, way back, you probably used to do problems that look kind of like this, where you're supposed to find the area of, and again, this is not, oops, this is even worse. You're supposed to find the area of maybe perhaps, this shape, which was contained by a rectangle. And again, not beautiful, but you get the idea. And this is supposed to be a square, of course, or a rectangle, but probably a square, actually. Um, so you were supposed to find the area, way back in like who knows what grade. You're supposed to find this area and this area and this area and this area. And how would you do it if you knew that this had a radius of, I don't know, let's say 3, for example? Well, if you knew that had a radius of 3, then you know that this is 6 by 6. So this is 6 by 6, so this is an area of 36. But you need to subtract out the area of this right here. You have to subtract out the area of this circle. So pi r squared says that that's 9 pi. And so that would be the area of the green. That would be this, 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 and this area. Okay. Again, not my most beautiful video or writing, but just trying to get it done quick. So how would we find this area? Well, we're kind of doing the same idea, but just half. So it's pi r squared, this whole thing, but it's over 2. So it's pi r squared over 2. And we know that this whole area here, this is 4 by, this whole area is 4 by 2. So that's an area of -8, right? But we actually want to subtract out the area of this. And this is also going to be a negative area in this case because it's underneath the axis. So just so you're aware. So just make sure it doesn't, you don't want to add 2 negatives to make this a bigger area. You're taking this away. So it's going to become less than -8. It won't be quite -8 because these 2 green things don't have an area of 8. So same idea, we want to find out what the area of the semicircle is. So it's going to be pi r squared, which is going to be 4 pi r squared over 2 because it's only half of a circle, right? And we're subtracting that negative area, so we have that. So we have 2 pi minus 8. So 2 pi minus 8. And then if we add 3 to both sides here, we cancel that out. That would be 2 pi minus 5. And that would be our answer for part D. Okay, so those are the things you're looking for in part D. All right, so let's move on to the next problem, the part D of the next problem that you were doing right here. So let's get in there a little bit and kind of look at what's going on. So we've got this derivative again. This is the derivative, and they do give you a couple of things. They give you that these are horizontal tangent lines. I don't know if we need that yet, and that's kind of it. So when does f have an absolute max? So that would need to be where like f prime would probably need to go from negative to positive. That would give you a relative max, so that's an option for your absolute max. So places where that could happen, here we have a relative max increasing. F prime is negative, sorry, absolute max, so I have my signs mixed up. We'd need positive to negative, right? We want the function to be increasing and then decreasing. So positive to negative. So we're looking for f prime to be positive, negative. This is the graph of f prime. So here we have a positive value, and here we have a negative value. So this is a potential. That's a relative max. This is not. So that's out. I'm trying to scribble on it, I guess. And then here we have a positive value. Sorry, I'll use green. Whoops. Here we have a positive value for f prime and then another positive value. So what can we say about the function? The function, if we look at it like a line here, right? We know that the function has something at -5, at -1, at 5, right? 5, -1. I'm just going to make a number line because this makes you feel better, right? And this, we'll call this y, we shouldn't call it y prime because they said that y was f prime. So this is f prime of x. We're not doing any real stuff here. We're really just like, what's going on here? We have a positive value, here we have negative, here we have positive, and here we have positive. So we have a function that is increasing, decreasing, increasing, increasing. So the function's increasing, decreasing, increasing, increasing. So the question is this, this, and actually it goes until 7. These are our options. One of these could be it. I would say that if we here at 5, right, we see this as increasing, increasing, so we have like increasing, flat, increasing, then we know that 5 is not going to be the absolute max, right, because it's going up and then it flattens off at 5. This is 5, okay, and then it goes up again. So 5's not our guy. For what value does it attain its absolute max? So now the question is this. The question is, could this be the absolute max? Right? Could that be the absolute? So the way that I would know how to do this would be this, right, is showing that f is decreasing. If we integrate this here, we get that we get a negative area, right? So this is like showing that it's going down. This is showing that it's going up, and it's going up for a long time, and it's going up at a pretty good, clip, I guess you could say. So what I want to look at is here. I want to look at this, okay, negative area. This is, down for the function. This area is kind of accumulation for the function getting bigger. That's the function getting bigger. And then the function again, right? So that's what we have. So if you look at the green, all this, good increasing, an accumulation of positive ground is all that green stuff, okay? So that's a lot of ground that we gained there, yeah? And all the ground that we lost since 5 was here. So if you look at what happened, we lost all of this area, but if you think about it, you could almost put that right here, right? That's this area. So did we lose or gain more ground over this, up until 7, up until this point? And you can see that we lost a little and we gained quite a bit. And for those reasons, we're going to have an absolute max at 7. X equals 7. You got to kind of have that discussion, and it's a lot to have. So if you listen to what I said, maybe I didn't write it all out, but that's kind of where you need to go with it. So that's it. Hopefully that made some sense. The big thing was kind of identifying those potentials right here from the number line, because you're looking at a graph of the derivative. And then as you integrate the derivative, right, you're accumulating. This is kind of like an accumulation of positive ground, negative ground, sorry, we're going down, we're going back, and we can see if it went like this, right, for like ever and ever and ever and ever, we'd have a huge negative area, and we would be going down like this whole entire time because we're at a negative derivative, and we'd be accumulating negative, we'd be losing ground this whole time. And that's not the case. We're gaining more ground than we're losing, more green than red here. So that's why 7 is the max, because it goes actually higher than this. So here's the like red part, right? We're losing for just this little while, and maybe we're losing it quite a bit, but then we're gaining all of this, and we're gaining even faster for longer in some ways, right? Because if you look at the height here versus the height here, this is a bigger value, y value, than this is, a negative y value. And this is happening for a long time, so we gain more ground. All right, that's it. I'll see you soon. Peace. I'll see you in the next video. Peace.